Hi, welcome to another Emerald Hill Skies live stream. My name is Doug. We're here on the outskirts of Louisville, Kentucky. And that strange image that you see in front of you is my attempt at trying to chase Mercury. Mercury right now is at an altitude of about 2 degrees above the horizon. You can see I've got some tree cover at 2 degrees, but I'm trying to coax a little bit of brightness out of this frame. And right there in the middle, I think, might be the planet Mercury. We're going to see here in a few minutes when it emerges. You know, Mercury is the closest planet to our sun, so it never gets very far away from the sun in the sky. That's kind of a disadvantage for those of us who want to do astronomy with Mercury because, for example, we can't really see it at night. So the only way to observe Mercury is when it's close to the sun. Right now, it's probably, 18 degrees away from the sun. That's probably some of the farthest away from the sun that it ever gets. But wow, being able to pull it out of the trees, that's like asking an extra lot. But my hunch is that, the telescope, as it travels, it's trying to keep Mercury in the same spot. And I do see some brightness right here. Of course, I can't tell if that's just the brightness of the sky, but right there, I think those are some electrical lines in our treetops. So that's a very good sign. The other thing that we might be wrestling with is a 4 or 5% cloud cover. And sure enough, I went outside a while ago and the clouds were right there banding along the horizon. So unfortunately, that's a reality. I've been observing since about maybe 4 a.m. this morning, and I've had a lot of clear skies. We've imaged several Caldwell objects, but boy, as I began to look for Mercury in the early dawn, kind of get ready for it, I began to see clouds kind of gathering. You know how they do sometime in that morning dawn light, kind of just hovering right there along the horizon. So we might be getting some cloud cover. Now I'm using a ZWO ASI 2600 MC Pro, but I've got it set for mono in an attempt to just use every last pixel to coax out whatever we can from the morning sky. It's got a capture area of 6,248 pixels by 4,176 pixels. It's an APS-C image sensor, so it has a lot of square pixel space on the sensor. But boy, through these trees, but sometimes I catch just a glimpse. Look right there. I catch just a glimpse of what I think might be Mercury. Now on the right hand side of your screen, you can see our planetarium software, Starry Night Pro, and I've got our field of view here. This is the red rectangle, and right in the center, should be Mercury, and this is the real-time field of view. Maybe you can see down below me in my picture over here to the right, you can see a picture of our RASA 11 telescope out in the observatory. It's about 200 feet outside, and it's on top of an Ioptron CEM70G mount. I'm sure you can see there in the observatory, it's just flooded with the morning light. I mean, sunrise happened, an hour ago, so to speak, when it comes to beginning to obliterate the night sky. But even though that observatory is flooded with light, you can see that we can at least kind of play with the camera here a little bit and try to get a little bit better sense of where we are. I'm using the display histogram to do an auto stretch just to kind of trying to coax what we can, but then I'm using the exposure slider here to try to dial in what would be the right exposure to see Mercury. And if you're watching, if you are an experienced Mercury observer, feel free, if you would, to let us know what's a reasonable way to be able to look at Mercury, and would you even try it in a situation like this? I don't know what your level of experience is. This is my first time to chase after Mercury, kind of go on an expedition to see Mercury. I'm playing with exposures here. We're at the equivalent of about a 4/2 of a 4,000th of a second exposure if you were thinking about a DSLR, but that's translating into 0.16 millisecond, one exposure right after another. Really, to be honest, this is almost like video level. We're taking so many frames, they're coming in so fast. It's, the equivalent of probably with USB 3 coming in, it's coming in over fiber optics from our observatory in a buried fiber optic cable. It's probably coming in at, I don't know, would it be 4 or 5 frames per second, I bet, by the time it comes in here. So it's just kind of almost like video frames. And we can just dial the exposure here to whatever you think is the best. That's obviously too bright. We want to dial it down so the night sky is a little bit darkened so that Mercury can just barely peek out. But like I say, right now we're wrestling with the trees. We're at about 3 degrees above the horizon. You can see with those being, I think, power lines. I think it's what those are. Can't tell for sure. We're definitely near the tops of our treetops, though. Here in a planetarium software, I do have a photorealistic horizon that we can look at, but it's not very dependable when you get down to this level. Let me just show it here, and you can see it's not at all dependable, is it? This close, but you can see some of the trees that we're battling. This is a photo view of the actual trees, and I have daylight hidden. We can actually show the daylight, but boy, that's not at all helpful, is it? But those are the trees that we're wrestling against. But you can see that I don't have this photorealistic horizon set exactly correctly, do I? It's a degree or two off, so we'll go ahead and hide that, and we'll just look at the night sky if we were to be able to see it behind the daylight. And then here we are, we're in the tops of those trees. Look at the wind kind of playing with the tops of those treetops. Obviously the treetops are out of focus because we're focused on the night sky, the planetary objects behind. You know that Mercury is basically, the closest planet to the sun. And so you got to be positioned just right to be able to see it rise. It's actually pretty small. It's about 5% of the mass of the Earth. And the only object that we've ever considered a planet in history that would be smaller than Mercury would be Pluto. So once we sort of made this decision, Pluto's out, then that meant that Mercury was the smallest planet, and it orbits the sun pretty quickly. It goes around an entire year's revolution in just 88 of our days. So it was named after that swift Roman messenger god, Mercury. Has no appreciable atmosphere, and the surface is heavily cratered. In fact, we can zoom in on it here, and you can see kind of the mapped image of Mercury here. And this was done, via a satellite that we made a few years ago that orbited Mercury and gave us this planetary image. In fact, we can actually show markers and outlines for it, and we can actually see some of the, let me just check all the different things we can show. These are the different, like here's the Kuiper crater here, and as we zoom in, some of these objects are going to be a little bit better defined. But again, these are all done via a satellite that orbited Mercury. We would never be able to actually see this through any telescope because to us, all it appears is just barely as an object. We can't even see its phases, The daytime and the nighttime surface temperatures can vary by as much as 600 degrees. So that's Mercury, and you can see we're getting very close to the treetops now. It's like this big expectation, isn't it, of a big reveal like, But in reality, we're not going to be able to see much if those clouds are out there. So again, we're chasing Mercury here. And the three things we're dealing with are the low horizon. Again, let's see what it is now. The real-time height is 4 degrees. So it's 4 degrees above the horizon. And you can see I've got trees there. So that's one thing we have to chase, is the fact that it's so close to the horizon and there's so much atmospheric disturbance because we're seeing it through a lot of airspace, And then another problem we are wrestling with is the light of the sun. And you can see that in the picture of the telescope out in the observatory below me. It's broad daylight out there. I can look outside my window and it's blue sky. Bright blue sky, at least in the part of the sky I can see out my window. So that's another thing we're dealing with, is the daytime. I've got the exposure lowered just so we're not blinded by the daylight, And then there are those waving treetops. Make sure. I guess if all things were equal, we should now soon begin to see boy, it's just like a drum roll, isn't it? Just waiting for this to happen. Let's back off here. So we are centered on Mercury there in our field of view, as you can see. There's our field of view. So Mercury would be very tiny in our field of view. Look, there are the power lines I've been waiting for. So those other things must have been lower power lines. Boy, I'm afraid there's some modeling, MOTTLANG, some modeling of some cloud cover back there. Look at that. You see those clouds. Again, I've got this ASI 2600 MC Pro changed to mono, and I've also put it on a binning of 2 by 2 binning, so it'll collect light a little better. And I've taken off the darks and lights since obviously I don't have darks and lights, darks and flats shot for 2 by 2 mono binning. I just don't have it done. I'm afraid those are clouds in the background. Look at that. So we're going to have to try this again, aren't we? Again, I was doing okay earlier this morning with the night sky, but those clouds have collected over there in the dawn light. So we're going to have to chase after Mercury another morning. This does let us know about where we are on this portion of our horizon, though, doesn't it? Now we have an accurate view. We start getting above the treetops at exactly 4 degrees and 43 minutes. So that's about 4.6 degrees roughly. And we're still not above those power lines there. But that tells me I've got roughly maybe a 5-degree horizon, right? But wow, I was really hoping to be able to see Mercury this morning. Got up at 3, got all showered and cleaned up and came here, opened up the observatory, did a couple of hours of EAA with the night sky, and I was really hoping to catch Mercury this morning. It's about 20 degrees away from the sun, like I said, so it's one of the best times of the year, or at least of the month, I guess, to observe Mercury. But we'll try this again and try to catch it on a morning when there are absolutely no clouds, because I think we're kind of into some clouds, and hopefully catch it right now at a point where we're at 5 degrees. But I'm pretty sure those are clouds and behind us. So what have we learned from this? Well, now we know we can switch our camera to mono. That's one thing that'll help. We can do this 2x2 binning. You can hear the morning birds singing outside. I don't know if I can take this camera and shine it out that window so you can see that's the broad daylight out there. Now there it looks like the clouds are breaking up some, huh? Can you see that sky kind of behind those clouds? So that gives me hope that we're going to get above the clouds, but whether or not we'll catch a glimpse. Mercury currently has a magnitude of 0.8, and that's pretty bright. That's as planets go, that's among the brightest, that you could ever hope for Mercury to be. But if the clouds are there, rascal clouds. So there's brightening it a lot, and then we're going down darker. Nope, I think the cloud cover over there is wrestling with us. But this is the way it is with astronomy. You have to deal with clouds now and then, don't you? Except if you're maybe the Hubble or the JWST, the James Webb Space Telescope. Anyway, thank you for joining us today. I'm sorry we didn't get to see Mercury, but that's part of it, right? And we'll catch it again. Boy, it's just right behind those clouds. I'm pretty sure. We would hope to catch glimpses of it right behind those clouds. If it were there. All this time, waiting for Mercury to rise. And the drum roll subsides, the cymbals clash, and nothing. But this is part of astronomy. You get up in the morning, you come here hoping to see Mercury, and there are those clouds in your way. Wouldn't it be great if we just caught a glimpse of it? Should be right there in the middle of the frame. Right there in the middle. Okay, now it's official. We are now, right now, exactly above the power lines. At, what is that? 5 degrees 28. So at 5.5 degrees. If we ever have to do this again, this is roughly our horizon. We can watch for Mercury at 5 degrees. It's interesting. You can see those clouds, can't you? This is a great astronomical view of a meteorological phenomenon known as cloud cover. I don't know how high we'll have to go to get above them. Well, we should probably call it a day. Thank you for watching part of this, and I hope you'll stop back by, and maybe if you like astronomy and you like chasing after planets in the middle of clouds, it would be great if you'd hit subscribe and maybe click a thumbs up for the channel, even if you don't like the clouds, and maybe even hit the bell, and that way you'll be notified when we do views of clouds like this. I wonder if we brighten that up some. If we can see a brighter view of the clouds. You can almost imagine what the sky would look like behind it there. But that's about it. That's our view. That's our attempted view of Mercury this morning. Boy, you just wish it would part. Oh, I just want to tell you that I see it right there in the middle. I want to say I see it. Okay, I'm going to say it. I see it. But I really don't. But it's right there behind those clouds. Mercury, It's a little dot, a bright dot. Not happening. Oh, I saw something move behind the clouds. See right there? You can kind of see the clouds playing in the morning there. Did you see it? I wish you would. 4% clouds, and the 4% have to be right here in the way of Mercury. Honestly, when I look out across the sky, I'm not seeing anything there. They're just bright blue sky. But as far as Mercury goes, not seeing it. Bummer. Maybe we should play in the background for this live stream. We should play the song Here Comes the Sun. It would be bright if we could see it. I mean, I think against this dark of a sky, we could have made it out. Boy, I see some brightness there in the middle. Do you want to pretend and say that's it? That's Mercury. Once again, we're going to go over here. And at least zoom in on it like this. So we can say that we saw Mercury, right? That's what Mercury would look like from a satellite view. Rats. Some of the best looking clouds I've seen. Real-time snapshots of clouds. Boy, it's right there where that movement is taking place. I know it is. You know, because our mount, it's an Ioptron Sim 70G. This RASA 11 has 11-inch aperture. It is mounted on top of an Ioptron CEM 70G, and the Ioptron is keeping us aimed at the place where Mercury would be visible if it were but visible. So in terms of our expedition, here are all the features. This Kuiper crater stands out. The rest of these, you'd have to get really close to start seeing them. Thacker. It is very cratered, isn't it? Well, let's call it. Boy, thanks for stopping by, and just sorry. This is why when astronomers greet each other or say goodbye, they often wish each other clear skies for this very reason. Thanks a lot, though, for being with us during this attempted viewing of Mercury. Boy, look, they're starting to thin. But it is 8:19. Would we really expect to see it in this sky? I mean, with the sun being, look at what it's doing to the telescope. Look how much it's illuminating the telescope. We'll have to try this again when there are no clouds. The imaging program we're using is called SharpCap. It does give you a high degree of control, as you can see over your camera. We have it on 0 gain, and this is about as quick. We have it on 0.03 milliseconds. So what would that be? I mean, not 1 millisecond, but not a, I can't even, is a that's a thousandth of a second, right? So the first decimal place would be a 10,000th of a second, right? And then, yeah, a millisecond. So a thousandth would be a 1 point, and then a 0.1 would be a 10,000th of a second. And then a 0.03 would be 300 thousandths. Is that right? Of a second? So this is about as quick of an exposure as we can take with this dedicated astro camera. No Mercury. Yes, clouds. Well, we're going to stop. But thank you for checking in with us and watching this attempt at Mercury. And this is part of the real story of astronomy, is trying things that sometimes don't work. Look how they're thinning out up there. God bless you, and thanks for spending some time with us on a laughing, what is this? Tuesday morning, a laughing Tuesday morning. We'll go ahead and stop the stream for now. We'll see you again on Emerald Hill Skies. Thanks, and God bless.